Welcome back. Problem 12-40. So this problem is taken from chapter number 12, Deflection of Beam and Shafts, and the book name is Mechanics of Material by RC Hibbeler. So statement is determine the slope at A and deflection of and C of overhang beam E is equal to 29 into 10 raised to power 3 KSI and I is 204 inch power 4. So you can see this is an overhang beam and there is a pin support at point A and a roller support at point B, and at this point we have a 6 kip load, and from B to C there is a uniformly distributed load of 2 kips per feet, and at point C we have 3 kip point load. So what we, due to this loading, the beam will deflect like this. Clear? So we have to find the slope at this point, which is theta A, and deflection at point C. So let's start with the solution. So first step is that if you remove this pin support, so you will be having a reaction force. Let this reaction force is RA, and if you remove this roller support, so you will be having a reaction force which is represented as RB. So we will find this RA and RB by using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0, and taking the counterclockwise moment as positive. So first moment about point A will be due to this load, which is 6 into perpendicular distance is 6, and this is producing clockwise, so it will be negative. So I will write it first, 6 multiplied by 6, and that will be negative 1. The second moment that is produced due to this RB force and this RB into perpendicular distance is 12, and that is producing clockwise, counterclockwise, so it will be positive. So I will write plus RB into 12. The third moment that is produced due to this distributed load when converted into point load, so this will be equal to 2 into our length, that is 6, is equal to 12 kip, and that will act at a distance of 3, because 6 divided by 2 is 3. That will act at in the middle. So this is 3 and this is also 3 feet. So due to this load, point loads, there will be a moment, and the perpendicular distance is now 15, and this is producing clockwise, so it will be negative. So I will write minus 12 into 15, and the last moment is due to this load, which is 3 kips into perpendicular distance is 18, and this is also producing clockwise, so it will be negative. So I will write minus 3 into 18 is equal to 0. So minus 36 plus 12 RB minus 180 minus 54 is equal to 0. So from here you will get 12 RB will be equal to 270, and RB will be equal to 270 divided by 12, which will give you 22.5 kips load. So this is the value of RB. Now we will find RA by using equation of equilibrium, that sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So RA is upward, so I will write RA, this is minus because it is downward, so minus 6 plus RB, which is upward, and that is 22.5, minus this 12 kips load, and minus 3 will be equal to 0. So from here you will get RA will be equal to 1.5 kip. Now you have both RA and RB, so we will go toward equation of elastic curve that can be obtained by using this formula, EI into d square V over dx square is equal to moment. So we will define the moment for this overhang beam. So for that you can see all the loads. This load is point load, this is also point load, this is point load, and this is distributed load, and we will neglect this load. Clear? So for that we will need table. So I am going to copy it from my previous problem and we will paste it over here. Okay, so we will take the help from this table. So moment equation will be equal to m will be equal to first load is point load RA. So we will go toward this and this is the moment equation. So load is upward, so it will be positive. So P will be replaced with RA and RA is 1.5. Okay, so this is 1.5. Okay, so kindly make a correction. This RA is negative. So it means that our assumed direction, which was upward, was wrong. So R should be in downward direction. Clear? Now you can see we'll start from this load RA. So moment equation will be this one. So load is upward. So this is positive. Here load is downward. So it will be minus 1.5 into x minus A. So A is equal to 0 over here. So x minus 0 power 1. The second load is this 6 kips. So again the same function will be used and load is downward. So it will be minus. So 6 into x minus. Now A is equal to 6 because x start from here. So A will be equal to 6. So x minus 6 power 1. The third load is RB, that is upward, so it will be plus, and RB is 22.5 into distance x minus total distance is this one, which is 12 feet. So A is equal to 12 feet. Clear? Power 1. And the last thing is that you have a uniformly distributed load that start from here till the end, and the distance A is for this load is 12. So we will go toward this equation. You can see this is for uniformly distributed load. So this load is downward and this is upward. So this function will be, in our case it will be minus. So minus m minus w naught is 2 kips. So 2 divided by 2 into x minus 12 power 2. So this is the equation of, I will write it again, moment is equal to minus 1.5 x minus 6 into x minus 6 plus 22.5 into x minus 12 power 1 minus x minus 12 square. So this is the moment equation. Now you will put, let this is your equation number A. So put the value of m in equation A. So you will get EI into d square V over dx square is equal to minus 1.5x minus 6 into x minus 6 plus 22.5 into x minus 12 minus x minus 12 power 2. So what we will do is that integrate this equation, integrate it. So you will get EI into dv over dx will be equal to minus 1.5 x square divided by 2 minus 6 into x minus 6 power 2 divided by 2 plus 22.5 into x minus 12 power 2 divided by 2 and minus x minus 12 power 3 divided by 3, and plus there is a constant of integration which is C1. So if you further simplify it, it will be equal to EI into dv over dx is equal to minus 0.75 x square minus 3 into x minus 6 square plus 11.25 into x minus 12 square and minus 0.33 or 1 over 3 into x minus 12 whole cube plus C1. Let this is your equation number 1. Now what we will do is that integrate equation number 1. So you will get E into I into V is equal to minus 0.75 x cube divided by 3 minus 3 into x minus 6 power 3 divided by 3 plus 11.25 into x minus 12 power 3 divided by 3 minus 1 over 3 into x minus 12 power 4, and we will multiply with this 3 plus C1 into x plus C2. So you will get EI into V is equal to minus 0.25 x cube minus 3 into 3 and 3 will cancel, so on we will left with x minus 6 power 3 plus 3.75 into x minus 12 cube minus 1 over 12 into x minus 12 power 4 plus C1x plus C2, and this is your equation number 2. So for finding C1 and C2, these are unknown constant of integration. So by using boundary conditions, we will find C1 and C2. So what are the boundary conditions? So at first boundary condition is that at x is equal to 0, we have deflection is equal to 0. So let me show you here. X is equal to 0, so you can see this is a pin support, so deflection will be equal to 0. So what we will do is that put in equation number 2. Why? Because equation number 2 is about deflection. So when you put it in this equation, this is the equation. So EI into 0 is equal to minus 0.25 times 0 cube minus 0 minus 6 whole cube plus 3.75 into 0 minus 12 whole cube minus 1 over 12 into 0 minus 12 whole power 4 plus C1 into 0 plus C2. So you can see this will give you 0 and this will be minus 6. Anything inside Macaulay bracket will be considered as that will be negative will be considered as 0. So minus 0 plus this term will be also 0 because minus 12 in the Macaulay bracket will be 0. This will be also 0. C1 into 0 is 0 plus C2, and this is equal to 0. So from here you will get C2 is equal to 0. Now we have C2 is equal to 0. We will use second boundary condition, and second boundary condition is that at x is equal to 12 feet we have deflection is equal to 0. So let me show you over here. So you can see at point B x is equal to 12 feet. This is the total distance. So here deflection is equal to 0 because there is a roller support. So put this in equation number 2. So I will put it. We will get EI into 0 is equal to minus 0.25 into 12 cube minus 12 minus 6 cube plus 3.75 into 12 minus 12 whole cube minus 1 over 12 into 12 minus 12 whole power 4 plus 12 C1, and C2 was 0. So 0, and this will give you minus 0.25 into 12 cube minus 6 cube plus this will be 0. 12 minus 12 is 0, and the same this term will be 0 plus 12 C1. So when you calculate it, It's very easy. Take the 12 cube and multiply it with minus 0.25 and then minus 6 cube and then solve this. So you will get C1 will be equal to 54 and the unit will be, if you do not write it's okay, but unit will be keeps into feet square feet. So this is C1. Now we have C1 and C2. So what we will do is that put C1 and C2 in equation number 1. Why? Because in our first part we have been asked to find to determine the slope at A. So equation 1 is about slope. This is equation number 1. You can check it. This is the equation number 1. So when you put it, so you will get EI into dV over dx is equal to minus 0.75 x square minus 3 into x minus 6 power square plus 11.25 into x minus 12 power 2 minus 1 over 3 into x minus 12 power 3 plus C1, which is 54. So if you divide EI on both sides, so you will get dV over dx, which is again equal to slope, and that is equal to 1 over EI multiplied by minus 0.75 x square minus 3 into x minus 6 square plus 11.25 into x minus 12 square minus 1 over 3 into x minus 12 whole power 3 plus 54. So this is the equation of slope. Now we have to find the slope at point A. So at point A is this one. So it means that at x is equal to 0, we have to find the slope at A. So put x is equal to 0. So this dv over dx at x is equal to 0 will be equal to slope at point A and 1 over EI into minus 0.75 0 square minus 3 into 0 minus 6 whole square plus 11.25 into 0 minus 12 whole square minus 1 over 3 into x minus 12 whole cube plus 54. So we will get theta A is equal to 1 over EI, and this term will be 0, this will be 0, plus 0 minus 0 plus 54. So we will left with theta A is equal to 54 over EI, and the unit will be keeps into feet square. Now we have E and I as well. E is 29 into 10 to the power 3 ksi kilo pound per square inch, and I is also 204 inch power 4. So what we will do is that we will convert this theta A is equal to 5 kips. So 10 to the power 3, you have to multiply 10 to the power 3, or if you do not want to convert it into pounds, so 54, and we will convert feet into inch. So 1 feet is 12 inch. So 12 power 2 divided by E, which was 29 ksi. So 29 into 10 to the power 3, 29 into 10 to the power 3 ksi. So ksi is there into 204. So when you solve this, you will get theta A comes out to be 0.0131 radian. So this is theta A, which is 0.00131 radian. If you want to convert it into degrees, so multiply. We know that 2 pi radian is equal to 360 degree. So 1 radian is equal to 180 divided by pi. So multiply it, so you will get the theta A in degrees. So this is answer of our first part. Now we will move towards second part, and in second part we have been asked to find the deflection at point C. So what we will do is that we will copy the equation number 2 Let me copy it. This is equation number 2, and note down the value of C1 and C2. So C1 was 54 and C2 is 0. We'll move toward next page. So this is equation number 2. Okay. So put C1 is equal to 54 and C2 is equal to 0 in equation 2 to get the equation of elastic curve. So UV is equal to, and divide EI on both sides, so 1 over EI into minus 0.25 x cube minus x minus 6 cube plus 3.75 into x minus 12 cube minus 1 over 12 into x minus 12 power 4. C1 is 54, so 54x, and C2 is equal to 0. Now we have been asked to find the deflection of end C. So at here you have to find deflection. So x will be equal to 18 feet. So you have to find deflection, which is VC. So put x is equal to 18 feet. We will get deflection at x is equal to 18 feet is equal to deflection of point C, and that will be equal to 1 over E into I, and x minus 0.25 times 18 cube minus 18 minus 6 cube plus 3.75 into 18 minus 12 cube minus 1 over 12 into 18 minus 12 power 4 plus 54 multiplied by 18. Okay. So again, when you solve this, you, you will get deflection at point C comes out to be 1512 kips into feet cube. Unit will be this, and divide by E into I. So we have E and I. So 1512 E is 29 into 10 raised to power 3 ksi, and I is 204. But here we have feet, so we'll convert 1 feet is 12 inch, so 12 cube. And when you solve this value will be -1. So when you solve this, you will get deflection of point C will be equal to minus 0.442 inch, or you can see that deflection of point C is 0.442 inch, and that will be downward. So this is the answer of our second part. And that was all about this problem 12.40. I hope you have enjoyed this video and you are learning from my videos as well. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest video which I post. And if you have any question, you can ask me in comment section. Thank you for watching. Also share my channel with your friends and help me in growing my channel.